Well, 2 weeks ago, there was an opinion poll run by Gallup in the US presidential poll. They polled 1,000 people if 984 turned out to be valid, and they said, what would you say are the 1 or 2 most important reasons why you lean towards voting for him or him? This was not a push poll. They weren't choosing between alternatives the pollsters set up. They were asked, what's your opinion? And those opinions were then translated into a list of 22 priorities. I know you can't read them. The top one, they want a fresh change or a fresh approach, and 21%. It's actually surprising when you think of George Bush's travails that not more than 20% actually gave that as the top reason. But nonetheless, that's the top reason. There's 22 reasons on that list, and here's the amazing thing. The bottom one, less than 10 people out of 1,000 think it's a significant exercise in their vote. On top of which, in the UK 2 days ago, there was a poll that showed 80% of the public are sceptical of global warming, and 40% think it's a media beat-up. Right, that's the sociology, back to the science. This is a graph of climate change, temperature in Antarctica in blue and in Greenland in red from today back 25,000 years, and here's this cold period, the last glaciation lasting from about 17,000 years backwards. And you see, again, the point I make, climate's always changing. And even when it changes between two states, a cold state and a warm state, it's still changing on the way. I've got a jig and a jog, and that big jig and a jog there is called the YD, the Younger Dryas. And this plant is a dryas, and its pollen is very common in lake beds that are studied to give you this record, and that's the name. Now what I want to do is take this period of time, here we're seeing it in 25,000 year context. I want to take that and look at it in more and more detail. Here's the first graph, coming in towards it. We're now looking at 5,000 years. Here's the Younger Dryas. This is cold, this is warm, so this is the start of our modern warm period going out here. 10,000, 11,000 through 15,000. Here's the end of the last glaciation. And you immediately get the impression that when we go from cold to warm, or warm to cold, or cold to warm, it's very rapid. The scale along here, each one of these ticks is 100 years. So we can't quite see how rapid, but it's clearly very rapid. What difference does it make? Here's a reconstruction. Here's the ice in the Arctic today, the red spots where the ice core came from, that last record was from, on the top of Greenland. And here's the ice front, and here's the United Kingdom. And reconstruction of the Younger Dryas winters is that the ice sheet is all the way down here, and there wasn't much shipping commerce out of the port of Southampton. Now, that scenario developed in 3 years. Paper published in Nature about a month ago. 3 years. We went from what we think of as typical today to basically a mini ice age. We do not know why it could happen again. So here we now got 150 year, 2 slices. This one's the beginning of the Younger Dryas. So we're warmer now. We've warmed up out of the glaciation, and we're now going into the start, basically, with the Younger Dryas here. And up here, I want to concentrate on. Here's the end of the Younger Dryas. This is the warm period we go out to today. Now that's about the length of time, about 80 years that it took, 60 or 80 years to come from fully cold up to peak warmth up here. But note, every step of the way the climate's varying, and we can go from almost full glacial to almost full interglacial here in a couple of years, because these wiggles are annual wiggles. That's the resolution of this climate curve. And what you also see is not only have you got the annual wiggles, but everywhere there's trends. There's a warming trend here. There's a sharp cooling there. Then there's another warming trend here. There was a cooling trend here, and so on. And these are multi-decadal trends. Every climate record in the world, when looked at in this detail, has this sort of behaviour. Climate always changes. And lastly, we're looking now at a pollen record for the last 5,500 years, up until today, to the year 2000. So BC AD, the birth of Christ there. This is from 5,500 to 3,000, and then it comes back here and here. So that's the record. And it's the temperature in northern Finland. And this scale here is about 1 degree in these larger, going from the warm spikes to the small spikes. So just look at that for a second. and let it sink in. Now look at where we are. And our warming just sits in here. It's much less warm than there, and then here, and then here, and then here. But more to the point, you can see there's this regular cyclicity, and the key message is climate change, both warming and cooling, is a natural hazard. The huge danger of this global warming hysteria, especially at a moment where the sun is quiet and the astrophysicists are predicting further cooling for 20 years, possibly even a little ice age, remember the title slide, Thames freezing over. At that very moment, we are hysterical about an imaginary warming trend. We are doing nothing about the real danger, which is natural climate change. It's a natural hazard. I go to New Zealand, it's a good country to look at natural hazards. They're nearly all associated with either the mountains or the sea. In the mountains, we have landslides. In 1991, 10 metres fell off the top of Mount Cook and came down here in a 12 million cubic metre avalanche. Nobody could predict it, nobody could stop it, it's a natural hazard. Most of New Zealand is hilly country. That hilly country is often unstable, as the countryside of Thredbo is here, or up around Cairns. Landslides are common. Here's one which came down the valley, and if there'd been a farmhouse sitting there, it would just have wiped it out, and that does from time to time happen. So landslides, a natural hazard, can't stop them. Tsunami in the Pacific, the east coast of Australia and New Zealand are both very subject to tsunami from earthquakes in Alaska here, or over here in South America. And here's the time. It takes about 18 hours for the tsunami to get from the Aleutians down to Australia and New Zealand, and we all know what happened from the dreadful tragedy in the Indian Ocean a few years ago. Can't predict them, can't stop them. Natural hazard. You have to react and adapt, The mountains are there because volcanoes have built them, and of course they produce ash which settles out and kills crops and animals. That's a hazard. And associated with mountain building are earthquakes. Wellington here is built on this linear fault, the Wellington Fault. This side is 400 metres higher than that side. It's been successively uplifted along little fault movements like this one of 2 or 3 metres a time. And one of those 3-metre movements is enough to destroy the city of Wellington. It will happen, just like San Francisco and Los Angeles. Can't stop it, it's a natural risk. New Zealand, not surprisingly, has taken account of this. And if we look at the risks, it's quite interesting. In New Zealand, the biggest risks going to do the most damage when it happens are earthquakes, volcanic eruptions coming on down. In Australia, it's actually the other way around. For us, the biggest hazards are bushfires and floods and storm damages, and these, while possible, are a very distant possibility. So in each country, you have to judge for yourself how you rank the relative risks. But all of these things are unpreventable, they're unpredictable, and climate change and sea level rise are exactly the same. New Zealand sensibly has set up a national agency called GeoNet, which warns the public about earthquakes, volcanoes, landslides and tsunamis. You'll note they don't yet have climate change in here, but they should have. They are linked to the earthquake, used to be the Earthquake and War Damages Commission, which is a national insurance scheme that recompenses citizens when one of these events happens, and through no fault of your own, you lose your house. Right. The government in Australia and the former government are failure of a duty of care. They have completely let the Australian populace down. Our current global warming policy, it's not a climate policy, it's a global warming policy, it's based on subprime science, subprime economics and subprime politics. It's like trying to drive this car that way. Australia needs a national climate policy based upon sound science, that's in yellow for a reason, sensible precaution and prudent risk management. It's in yellow because computer modelling of climate is not predictive science. And if you ask the computer modelers, they will confirm that. The first and necessary step is the convening of an independent review of the dangers posed by all types of climate change, cooling as well as warming. Adaptation to climate change is of the essence.